Negative minus 2i.
Okay, that's the one, okay? If you have a real number, the real number will not change signs. It's the one in front of the I that will just keep on switching from opposite. So the complex conjugate of 2 plus 2i will still be 2. That doesn't change, but the one with the I is the one that will change. So it's 2 minus 2i. So the only sign that will change is the one in front of the I. Okay, so let's, okay. In number 9 and number 10, we're asked to write the complex conjugate, and they give us the complex number. Then we're going to multiply the complex number by its complex conjugate. Because when you multiply, like number 8 is complex conjugate. Okay, when you multiply, you only do a squared plus b squared. In other words, there's a formula to find it without doing all the FOILing, in other words. And that's why we got a number only, because the only thing that we need to do here is to just square the square root of 2 and square the positive 8. And that will give you 10 already. So if you do it here, your a is square root of 2, so it's square root of 2 squared, and it's always plus between them. And then your b is square root of 8, and all you need to do is to just square it again. Square a, square the b, and then add them up, and that will be the answer already. Because what's this? Square root of 2 squared is? They cancel, so that means it's just going to be 2. And plus square root of 8 squared, cancel again, so it's going to be 2 plus 8. Isn't that what we got? 10? Yeah, because that's the shortcut. For complex, as long as you're multiplying complex conjugates, you just do a squared plus b squared. And that's why 9 and 10 are like that. Okay, so what is the complex conjugate of 1 plus 2i? 1 minus 2i. And then multiply. What is the product if we multiply the two complex conjugates? In other words, what is 1 plus 2i times 1 minus 2i without doing FOIL? All we do is just a squared plus b squared. The a is the real number, and the b is the numerical coefficient of the one with the I. No i's, in other words, just the a and the b. Okay? So a would be 1 squared, and b is 2, so it's going to be 2 squared. And what's 1 squared plus 2 squared? 1 plus 4, so that means the answer is 5. Without doing all the FOIL, the answer is just 5. You just do a squared plus b squared. Okay, remember, this only works when they're complex conjugates. Right, number 10. Stop sign, okay, you have a square root of negative 3. You cannot do the I. Okay, you cannot do it yet until it's a positive square root. Okay, in other words, it should be positive under the square root sign. So how do we change it into positive square root of 3? You have to put the I. Okay, so it's going to be negative 2 minus, make it positive 3 now, but put the I at the back. So now it's in standard form. Okay, so what's the conjugate of negative 2 minus square root of 3i? What's the only sign we need to change?
The negative in between the 2 and the square root.
So it's the minus sign or the negative between the negative 2 and the square root of 3i. This is the only sign that will change, not the one in the front. The one in the front does not change at all. So this is negative 2 plus square root of 3 and then the I. Okay, all we do is just put the plus sign. All right, okay, without doing FOIL, what will be the product?
Negative.
It's going to be the negative 2 squared plus the square root of 3 squared. No i's, in other words. And that will give us 4 plus square root of 3 squared is, they will just cancel, so it's just 7. So it will be 7. So without multiplying, without doing the FOIL, well, the product of the complex conjugate is will be positive 7. So it's just a squared plus b squared. Alright, let's do the one in back. We did adding, subtracting, we did multiplying, we haven't done division yet. And that's why we do complex conjugate, it's because of the division. Alright, so if you look at the problem, it says write the quotient in standard form, and then it says hint. Okay, we don't really divide, we multiply the numerator and denominator by the conjugate of the denominator. Because as soon as you see a division bar or a fraction, there should not be an I in the denominator. Okay, so to do that, okay, to make it disappear, we're going to multiply it by the complex conjugate of the denominator. So the denominator here is 1 plus 2i. That's the one that we're going to get the conjugate of, not the numerator, the denominator. So what's the conjugate of 1 plus 2i? 1 minus 2i. So we're going to multiply, okay, both numerator and denominator. So the 3 minus I, we're going to multiply it by 1 minus 2i. And the denominator, 1 plus 2i, we're going to multiply it by 1 minus 2i. So this will be 3 minus I over 1 plus 2i. That's the problem that we're given. We're going to multiply it by the complex conjugate, which is 1 minus 2i, and also the numerator, 1 minus 2i. Okay, and we can do that because what's 1 minus 2i over 1 minus 2i equal to? 1. So we are not changing the problem. We're just rewriting it in our words. Okay, so that we can't have an I in the denominator. So this is multiplication. So that means we're going to do FOIL on top. But in the denominator, remember we have complex conjugates. So all we need to do is to just do a squared plus b squared in the denominator. So first the numerator, we're going to do FOIL. So 3 times 1, 3. 3 times negative 2i is minus 6i. Then I'm going to go to the 1 in the back, negative I. I'm going to multiply it to positive 1. So that means 1i, minus 1i. Then we have a negative I times negative. So that would make it positive. And 2i times I squared. Okay. Then let's work in the denominator. Okay. They're complex conjugates, so we just square the a, square the b. The a is 1, so 1 squared. The b is 2, so 2 squared. What's that?
5.
That would be 5, right? So the denominator then is 5. Okay, but in the numerator, we have to simplify. We need to combine like terms. But what happens when it's I squared?
Negative 1.
That's going to be negative 1 times 2, so that would become negative 2. So we're going to combine 3 and negative 2. And what's 3 plus negative 2? 1. So the real number is 1. What about the imaginary? Going with the I. Negative 6i minus 1i? Negative 7i. Alright, one more step though. Remember, they want our answer in standard form. So we need to separate the real number from the imaginary. But they have the same denominator, so all we need to do is to just rewrite it separately. So first the 1, we're going to put it over 5, because that's 1/5, right? Then since it's a minus between them, you're going to put minus between them also. And then of course, it'll be 7 on the numerator and 5 in the denominator. And then the I. Just separate the imaginary from the real. Okay? Because all our answers should be in standard form. A plus bi. Okay? So this is your final answer. Now look. Since we end up with a fraction, okay, if they need to be reduced to lowest terms, you need to make sure that they are in lowest terms. Okay, but this one, you can't reduce it anymore. So we're just going to leave our answer like this. All right, number 12. You have 1 divided by 2 minus 3i. And again, we cannot have I in the denominator. So to get rid of it, we're going to multiply by the conjugate. Every time that you have an I that you need to remove, you multiply it by the complex conjugate. Okay, if it's in the denominator. So what is the conjugate of 2 minus 3i?
2 plus 3i.
It will be 2 plus 3i. So we're going to multiply the original problem, 1 over 2 minus 3i, by the conjugate. So we're going to multiply it by 2 plus 3i and 2 plus 3i in the numerator as well. Right? So first, numerator. It's just 1. 1 times 2 plus 3i? will be the exact same thing, right? Multiplied by 1 means it's going to be the same thing. But use the denominator. Remember, the denominator are complex conjugates. So use the a squared plus b squared. So a is 2 and your b is 3 or negative 3, whichever you want to do it. So it's going to be 2 squared plus 3 squared. You can just drop the negative because when you square a negative, remember it's also positive. So all your answers right here are all going to be positive. You're never going to subtract. It's always going to be plus. Okay, don't forget. The denominator is always a squared plus b squared. It will never be minus b squared. So this would be 2 plus 3i over 2 squared is 4 and 3 squared is 9. 4 plus 9? 13. But we're not done yet because they want our answers in standard form. So we have to separate the real number from the imaginary. But the denominator is just 13. So you just put this, okay, with 13 as denominator. Then it's a plus sign between them. And then the imaginary 3 over 13i. Can we simplify 2 over 13? No. 3 over 13? No. So that means this is already your final answers. Okay? So when we're dividing, we're not really dividing. We're not doing long division or synthetic division. We're multiplying by the complex conjugate. Because we just want the I in the denominator gone. That's why we multiply by the complex conjugate, so it'll be gone. Instead, we just have a number in the denominator. Okay? All right. Quadratic formula.